radiologist or an electrical engineer and you asked them if they thought this was a stable system, they would tell you, no, it's definitely destabilizing, because when we see these abrupt jumps in the data, those are the ends of each ice age. They illustrate that really powerful amplifying feedbacks within the climate are propelling rapid change. The climate system is still sort of bounded. It shuttles between the depth of an ice age and the short-lived warmth of what we call an interglacial. But these are dramatic changes happening when, in fact, it's all driven in the past by pretty subtle changes in the Earth's orbit, and yet we get the order of 4 degrees of global warming, and we have 120 meters of sea level rise at the end of an ice age. And it's against that backdrop that we've already driven the carbon dioxide level in the atmosphere up to about 415 parts per million. And in the rest of my lifetime, we might still be going up towards the top of the chart here. So against this somewhat unstable backdrop, if we hit the climate that hard, we shouldn't be too surprised if we're going to pass some damaging tipping points in the climate system. So that's my aim, to just summarize what we know about those in general terms first, one of the biggest risks we're running with climate change in essence, but then switch it round and talk about how the same kind of complex systems thinking and tipping point thinking could be part of our salvation, how we might be able to identify and trigger some positive tipping points to accelerate tackling climate change and the ecological crisis. So this is a little toy model of a system that I'm slowly forcing towards and eventually past the tipping point. And it's the ball rolling in the valley is a system is in one possible stable state, but there's another state it could be in. And I'm destabilizing the state that it started in. So at some point, a little bit of a nudge is going to be enough to tip the system into another stable state. I'll run it one more time, because this is just me helping us get our eye in for the kind of, what we say, dynamics that can happen sometimes in complex systems. So when we draw the ball in the valley, we're saying there's some damping feedbacks that maintain the status quo, but I'm making those weaker as we go along. And at some point, some amplifying feedbacks, some things are going to amplify change within the system and propel the tipping point there from one state to another. And as we'll see in a minute, there's a whole bunch of bits of the climate that have different stable states, and they could be tipped between them. But this, as we'll see later, also applies to major parts of society, our relationship with energy, or our energy systems, our relationship with ecology, and so on. So this is a little summary of how academics have spotted tipping points and the whole range of systems in which tipping points can occur on different time scales on the x-axis and space scales on the y-axis. So we're ranging here from events deep in Earth's history, some of the events in green and gold, in gold and text up here, through to some climate tipping points I'm going to talk about. But then there's a whole range of ecological systems. The blue ones here, sort of aquatic ecosystems, the green ones, terrestrial ecosystems, the grey ones, things at the boundary of the land and the water, whole range of ecosystems that can exhibit tipping points. But then lots known about how social systems sometimes have tipping point changes. Things like the Industrial Revolution, or in the worst case in the past, the breakdown of civilizations. But later on, I'm going to come and try and talk about some positive social system tipping points that we could together trigger. But first, I'm afraid, a little bit more of the bad news on the climate tipping points, just so we're all on the same page of how we understand the risks we're running with climate change. So just before I get to the present and the future, I just have to show you one more thing about the past. Now I'm looking within the last ice age. I'm looking at a measure of temperature as recorded this time in Greenland, again from an ice core drilled into the ice sheet. But what we see numbered there are multiple abrupt climate changes where the climate warmed up, say, 8 degrees centigrade in the space of a decade or two. And that was not just in Greenland, it affected the climate across the whole North Atlantic region and had repercussions all the way around the world. So it's just serving to emphasize that the Earth's climate was not particularly stable before we really started hitting it hard. And if we zoom into the end of the last ice age, it's quite convulsive. There's a really abrupt warming, and then it oscillates, and then there's abrupt cooling, and then we finally have another abrupt warming out of the ice age. And then we like to comfort ourselves that the last 10,000 years in which all our agriculture and civilizations developed looks kind of somewhat more stable as viewed from Greenland or the North Atlantic. But actually, if we looked in a record from the tropics, we would see that there are big shifts in the water cycle, and there are switchings on and off of major monsoon systems correlated to these changes we're seeing in the North Atlantic here, and often correlated to the rise or the fall of past civilizations. So that's one source of evidence, all of that kind of abrupt change going on in the past, to give us clues about which bits of the climate are less stable and which bits might be prone to being tipped by our activities. In particular, those abrupt climate changes I was just showing you, they involve fundamental shifts in the circulation of the Atlantic Ocean, including the formation of deep water, which happens kind of in these yellow spots either side of Greenland. But we've also got other sources of evidence that allow us to put some things on a map here. So we have our climate models that we run into the future, and we look inside the model world, and sometimes we see abrupt changes happen in the model in the future, like the dieback of the Amazon rainforest or the boreal forests, or the thawing of the permafrost, which we begin to see in observations, of course, as well. So it's those sources of evidence, and also our basic physical understanding of feedbacks, as we call them, within bits of the climate, that allowed us to begin to draw up a map like this of what I called the tipping elements in the climate system, the bits that could be prone to being tipped by human activities, or one that had already been tipped, the Antarctic ozone hole, in my lifetime. Now, there are things we need to know if we think that there's these kind of risks lurking is well, how close are they, as it were, the tipping points, as well as how bad would the impacts be, and to whom. So I'm going to talk a little bit more about our assessment of the likelihood of tipping points from a scientific point of view, expressed in terms of how much global warming on the x-axis does it take before you're risking crossing some of these climate tipping points. And I'm showing you here how the climate science assessment of that has changed over the last 20 years or so in successive reports of the Intergovernmental Panel on Climate Change. So you have at the top 2001, 20 years ago, we thought that it would take 4 or 5 degrees of global warming before we were really seriously risking some climate tipping points. Well, that wasn't good news, but at least it was a fair way off. Unfortunately, over time, with successive reports, we bring our estimates of the temperature at which we risk crossing tipping points closer to the present temperature. Of course, ironically, at the same time, we are busy driving the temperature up. So that by the time you get to a couple of IPCC reports in 2018, 2019, our assessment is that we're already risking significant risk of crossing some tipping points at the present level of about 1.1 degrees of global warming. Certainly at a fairly, I'd say, high risk of crossing some at 2 degrees of global warming. And that's one of the sources of scientific evidence behind why there's been such a concerted push in the whole COP26 in Glasgow to try and get nations towards committing to a world where we limit the warming to 1.5 degrees C. But unfortunately, even that may not be totally safe, because we already see evidence of accelerating change in the wrong direction in bits of the climate that we'd previously identified as being prone to tipping points. So, for example, we have accelerating melt of the Greenland ice sheet, with the accelerating loss of the Arctic sea ice. We have a slowdown of the Atlantic's great overturning circulation. We're seeing unprecedented droughts in the Amazon. And down here in West Antarctica, we've got the most sobering evidence that we might have passed the tipping point for part of the ice sheet, where the glaciers are retreating in a way that starts to become self-propelling. And glaciers in question, as they go, they ultimately could drain ice that would raise the sea level by over a meter. And then they might destabilize the rest of the ice sheet down here, which would give you about 3.5 meters of sea level rise. So that, combined with the risk that we're close to a tipping point to lose the Greenland ice sheet, which would ultimately eventually lead to 7 meters of sea level rise, you add them up, you start thinking, wow, on a long time scale, we might already be risking consigning some of our descendants to 10-meter higher sea level. That the only saving grace at the moment is those ice sheets are melting relatively slowly, and the sea level rise is relatively slow. But unfortunately, it starts to self-accelerate if we cross the tipping points. And it's further bad news when you start looking at the interactions of bits of the climate system. So basically the story is that tipping one thing seems to, in many cases, increase the likelihood of tipping another. So we know that the Arctic is warming up at an unprecedented rate, about 2 or 3 times as fast as the global average, because the great big white reflective surface of sea ice is being melted and replaced by a very dark ocean that absorbs a lot more sunlight, heats things up and melts more ice. That in turn that accelerated warming is contributing to melting the Greenland ice sheet next door and thawing the permafrost that releases carbon back to the atmosphere. And all the fresh water that pours off Greenland and the extra rainfall and snowfall that's happening in the Arctic as it gets warmer, this affects the Atlantic circulation. It freshens up the otherwise salty waters of the North Atlantic, makes them less prone to sinking, which is what they would normally do either side of Greenland. And that has the potential to, well, it's already weakening the great circulation of the Atlantic Ocean, which drags water and heat from the southern hemisphere across the equator northwards. And Earth's history tells us that when you weaken that circulation, you drag rainfall all the way around the tropics southwards. So you disrupt the monsoons in West Africa and India and in South America. And you leave heat behind in the Southern Ocean, which is a problem for threatening or destabilizing the ice sheets that are around and on Antarctica. So, yeah, in simple terms, it's a coupled system, but coupled in an unfortunate way where changes could start to cascade through the system in a bad way. Which is why we raised the warning flag a few years ago that if anyone survives that and lives to look back on it, they might end up perceiving it as just like passing a global tipping point into some other climate state with a higher sea level and a stable but hotter climate. We emotively called it a hothouse Earth, but the key point, I guess, is we don't know where a threshold for a hothouse Earth resides, if it exists, but we know we should try to avoid that at all costs. So yeah, that's perhaps the blindingly obvious, that we can't afford to go there. We're already destabilizing the climate. We need to do some things to restabilize it for all of our futures, as well as our children's and our grandchildren's and their children's futures. So that's enough bad news. And then this is the sort of framing diagram for Glasgow, for COP26, for the whole climate negotiations that have been going on. If we want to limit global warming with a 50% chance of limiting it to 1.5 degrees C, we'd have to stop going up the green line of increasing global greenhouse gas emissions and go down the red line where we halve emissions by 2030 and we get rid of them altogether by 2050, if not before. Because some of us are not confident that what's portrayed here in the latter half of this century some massive net greenhouse gas removal from the atmosphere. We're not really convinced at all scientifically that that's feasible. So if it isn't, we just have to shut down all the emissions sooner. And that means spectacular rates of social, technological, ecological change. It means something like more than a 7% year-on-year reduction in greenhouse gas emissions. It means decarbonising the economy by a rate about 5 times faster than we're going at the moment. And that's why I wanted to spend more time talking about positive tipping points. Basically, the simple version is the only chance we have of doing that is if we can find and trigger some positive tipping points that are going to accelerate self-propelling change in society, in technology, and so on. Right. So to talk about that, well, I'm not the only person saying that. There's a growing sort of groundswell of interest in the need to identify and trigger some positive tipping points. And this diagram from a different group looks a whole lot like my little toy model I showed you. But now it's conceptualizing one stable state is like the business as usual state of the economy and societies. But there's another state where we've got ourselves off fossil fuels. We've transformed everything, and we're at zero greenhouse gas emissions. The trouble is, of course, the current way of doing things. There are various damping feedbacks that stabilize it, like fossil fuel subsidies, for example. We could cite many others. So the trick here in thinking about how do we lower the hilltop, it might be partly about taking away those processes, those damping feedbacks that maintain the status quo, but it's also about identifying and triggering some amplifying or reinforcing feedbacks that can propel change, because those are the things that we know are behind tipping point dynamics. And they're the things I want to talk about. What are those feedbacks? Where are we going to find them? But first, we might want to convince ourselves that we can change rapidly, and we have changed rapidly and profoundly in the past. And social norms, behaviors, technologies, they've all changed abruptly at times in the past. Not all of the time, but it can happen. To begin to illustrate that on the social side, this is a distant relative of mine. You might not recognize the family resemblance, but this is Lillian Lenton, pictured in 1913. The number gives you a clue that she's actually in prison when this photograph is taken. Why is she in prison in 1913? Well, she was implicated in burning down the tea house in Kew Gardens in London because she was one of the most active suffragettes. While she was in prison, she went on hunger strike, as did many of the suffragettes. She was one of the ones unlucky enough to be force-fed in prison, and I'm afraid they put the tube down the wrong way into her lungs, and they poured liquid food into her lungs, which of course nearly killed her. Now, the government then made out that Lillian was ill just because she'd been on hunger strike, but it soon became obvious and transpired that that was a cover-up. And it became publicly known that the government were covering up what they'd done. And that was one of several things, of course, that turned public opinion against the then government and more in favour or more sympathetic to the move for votes for women in the UK. I'm not saying that the change then happened super fast. And it was also, of course, encouraged by the huge role that women played in the First World War, but the vote certainly did start to change in 1918. It was given to women over the age of 30. That did not impress Lillian because she was under 30 at the time. It took a bit longer, 1928, before we finally got to the point in the UK where half of the adult population could join the other half in democratically voting. Now, that's a past profound change in our democracy, but we're also seeing really real-time examples of abrupt change in society. And this is somebody you all know. Greta was the beginning of a tipping point change, which followed classic, we would say scientifically, classic dynamics of tipping point. By protesting, by skipping school on a Friday and protesting in front of the Swedish Parliament, Greta makes it incrementally easier for the next person to join her in the protest. And that makes it incrementally easier for the next person, and so on. And then this started to snowball, of course, so that quite within months, you had hundreds of thousands of people in cities around the world marching to demand more political action on the climate crisis. And soon enough, political declarations certainly followed. So this is the European Parliament voting to declare a climate emergency in November 2019. So far so good, except as we've all seen, rhetoric doesn't solve the climate crisis, only actions do. So the big question becomes, can we tip decisive actions that actually reduce those greenhouse gas emissions and transform the way we live with lots of other co-benefits? So I want to start to move into the realm of action and change in technology and other elements of our society. And what we were just looking at with Greta's example is a form of what academics call social contagion. In that case, a sort of pure contagious spread of norms, if you like, or political position, stated political position. But contagion can happen where people follow or emulate each other for changes of norms, changes of behaviors, and for changes or uptake of technologies. And it can sometimes these things spread exponentially through a population. And interestingly, we start to see the accelerating contagious spread of sustainable technologies. So that's true of solar panels on the roofs of houses. People have been clearly sort of copying their neighbors, if you like, and we see evidence of social contagion for solar uptake. This is an example in a little video of that happening in part of the US, in part of Colorado, but it's been observed in very different geographies and cultural contexts as well. So that should begin to give us some hope that there's sort of potential for fast change in technology. I just want to step back into history, back a century again, back to Lillian's time, and look at a classic example of how quickly technology and our relationship has changed in the past. So this is a classic example of modes of personal transport. It's Easter Parade, Fifth Avenue, New York City in the year 1900 on the left there. And the challenge is to spot the automobile when everyone is in a horse-drawn carriage. Not sure if you've spotted it yet. It's a bit of a grainy photo, but basically it's lurking right there in the left-hand side of the shot. 13 years later, the converse challenge is to spot the horse-drawn carriage when everyone else is in an automobile. It's the same street, it's the same Easter Parade in New York City. It's 13 years later. Everyone's in an automobile, one person's left in a horse-drawn carriage. They're actually in a similar position on the street over there. And this transition, this profound transformation in personal transport happens across US cities in roughly that decade. In the middle of it, at some point, 30% of the cars were battery electric. And it's said that it was Thomas Edison of light bulb fame who talked Henry Ford out of electric battery car technology and into the internal combustion engine. Then we have the Model T Ford, and the rest is, as they say, history. Now, that's not the only abrupt change in uptake of technology. In fact, it's a sort of general rule that you could get accelerating uptake of new technologies, and there are a load of examples on the left here. But the key point is that's because there are a load of reinforcing feedbacks behind our relationship with technology and how technology itself develops. So the more something gets made, the better we get at making it. We call that learning by doing. Also, the more something is made, the more cheaply it can be made, and we call that economies of scale, and that's super powerful and important. And then something a bit more subtle, when we get a new technology, the more it gets used, the more other technologies emerge that tend to make it more useful. So as we turn to the future, there's complementary technologies like electric vehicle and charging network. Neither are very useful on their own, but they work well together. So that's going to bring me towards returning to personal transport, because we're just beginning to see a tipping point finally for electrification of personal transport. I'm going to concentrate on cars, but of course we're seeing it with electric bikes and scooters and all manner of things. It's happening first, at least for cars, in Norway. And it's a classic example of how some social innovators can be the beginning of what becomes a profound change. The social innovators in this case being the pop band a-ha, here pictured in 1989, working with this character, Frederick, who's converted this car that a-ha bought off him, a Fiat Panda it was. He converted it to an electric vehicle, a battery electric vehicle. Stated range, I think, was about 45 kilometers. But a-ha imported it into Norway, and they persuaded the Norwegian government not to charge a import registration fee for the vehicle. And that was quite a big deal. They argued it, persuasively, that this was a clean car, so they shouldn't have to pay that tax. But that's a big tax, because no one makes cars in Norway, and I think it was of the order of 10-20% of the total value of the vehicle for any typical car put on the road in Norway. So that immediately starts to create enabling conditions for a shift to electric vehicles. Then a-ha proceeded to argue that they shouldn't have to pay road tolls for this clean car, so they would keep driving the car through the toll booths and not paying, and the police would keep confiscating the car, and they'd keep refusing to pay the fine. Then they'd buy the car back at auction for less than the cost of the fine, and this cycle repeated itself apparently for about 8, 9, 10 years, until eventually the government caved in and they waived road tolls for electric vehicles, which again creates an incentive to switch to an electric vehicle. The government then cottoned on to the fact that this would be a positive transition if they electrified transport in Norway, and they started introducing their own incentives, like giving electric cars access to the bus lanes, so that meant people in Oslo would get to school or get to work twice as fast if they were in an electric vehicle. Well, one thing led to another, and now if you were to go to the streets of Oslo, you sort of enter a world that looks like this, where electric cars are dominating. And this is just showing you that in real data. It shows that since 2011, when the electric cars were a tiny part of the market, they've gone to become the dominant type of car sold as of 2020 in Norway. And petrol and diesel cars have just disappeared from new purchases over in the space of a decade. And to look at it another way, we plotted how does the market share for electric vehicles in Norway versus other European countries depend on the price difference to the buyer, to the consumer at the dealership. So in Norway, thanks to several of the things I mentioned, and also some progressive tax incentives, if you like, or use by the government, it's the same price to buy an electric car as a petrol or diesel one, and lo and behold, people opt for electric cars. With the rest of Europe, the minus signs show where it's still more expensive for an electric vehicle relative to a petrol diesel one, and we just have 5 or 10% of new cars being bought or sold are electric. But the Netherlands, we were predicting, would tip next, and indeed it has. So we begin to see a transition there to electrification of a key part of transport, and we begin to see some clues as to how it can be tipped to happen. And the good news is, once it starts happening, it becomes self-propelling, because basically the thing that would currently be making electric transport more expensive is the cost of the batteries. But the more batteries that gets made, the cheaper the next battery becomes. There's amazing economies of scale for batteries, and that's what this little plot here shows, how the price of the battery pack declines as the number of battery packs made increases. And what that means is very soon electric vehicles are going to get cheaper to make than petrol or diesel cars because they have fewer moving parts, the electric vehicles. And at that point, we'll really see this spread. But for now, we can talk about how Norway is a brilliant example of how clever, deliberate use of policy, as well as public support, can tip a profound change. And if other countries like the UK, but all over the world, were to seek to emulate that, they could trigger this tipping cascade or change to happen sooner, because they could basically be triggering these economies of scale to kick in. And as they kick in, it's going to have all sorts of interesting collateral benefits. You're going to get loads and loads of ever cheaper batteries, which is good for other things. It means that you could begin to see a tipping point where you electrify goods and transport, at least light goods transport. It might stop the oil firms from carrying on with business as usual and actually stop hedging their bets and commit to reinventing themselves as a different kind of company. And most interestingly for me, cheap batteries starts to interact with something else even more important than electrifying transport, which is the transition to renewable energy. Because basically, the only real issue with renewable power is that when you want to boil the kettle isn't necessarily when the sun's shining or the wind is blowing. You have to be able to match supply and demand. So you need some cheap storage form for electricity, and lots of cheap batteries. It could be a key part of that and could really enable the renewable power revolution. So that's what I want to turn to as my second main example of where tipping points are really starting to happen for power generation. And to preamble for that is we are being misled by mainstream economists, as we've sort of begun to see with the electric car example in Norway. Mainstream economists are persistently arguing that the more we want to tackle climate change, the more we want to abate greenhouse gas emissions, as they call it on the x-axis here, the more it's going to cost us. In fact, it's not even a straight line. In their view, when you want to get rid of more greenhouse gas emissions, the more you want to get rid of, the more expensive it gets to abate the next unit. So the curve sort of steepens upwards. So it's like they think the world is like this. They think it's like, I think he was called Sisyphus, it's pushing the boulder up the hill. And it's even worse. In fact, in the economist's version of the world, the hill kind of gets ever steeper and it gets ever harder to push the boulder. But the key point is, as you sort of could see with electric cars, it isn't like that. There can be an alternative stable state. And there can be a tipping point that you get past where the transition to a different technology, in this case, it becomes self-propelling. And that's a crucial part of our salvation, hopefully, in tackling the climate crisis. So I want to just show how this has been true, or how it's been manifested in power generation for the example of the UK. Sorry if it feels a bit parochial, but it's illustrative and it's informative to see how another key tipping point has happened and what made it happen. So in the UK, we've had a big, we're working off the back of globally lots of research and development of solar and wind power, renewable energy. But we've also, as the taxpayer, been happily subsidizing the deployment of lots of renewable energy in the UK. And also the government has been doing useful things, reforming the power sector. And this is sort of has been moving us towards a tipping point anyway. But on top of that, some fairly smart use of policy to put a price on carbon emissions just for power generation was able to completely tip the power system in the UK, as we'll see in a minute. So it's a slightly complicated story, but what we had is a situation where, if you imagine being what in the UK is called the national grid, the people who try to have to make sure that electricity supply meets demand. If you're sat in their control center, what you do is you take all the renewable energy generation capacity onto the grid that you can, because that's basically generating for free once it's installed. And then you probably take the nuclear power we have, not a great deal, but some. And then if you've still got demand for electricity, you're going to go to a fossil fuel. And the one you would normally go for, the one that's the cheapest, is a coal, of course. But it's also the dirtiest fossil fuel compared to natural gas, twice the CO2 emissions per unit power generated from coal compared to natural gas. So what was done in the UK quite effectively was to put a price on carbon emissions in the power sector and get it to the point where it was sufficient to make gas the economic option to go for next rather than coal. And that's what this really complicated plot is all about. It's a plot about what I've just described is what's called the coal to gas switching price. It's sort of the price that there needs to be in this case on carbon emissions. Well, comparing that to this coal to gas switching price, basically you're trying to reach the tipping point I described. And it's pictured here happening. So you have in grey the price on carbon emissions from the EU's carbon trading system, and it fluctuates and it's rather low. But then in blue, we have the deliberately introduced price on carbon emissions in power generation in the UK, and then it's stepped up a couple of times. And then when the red wiggly line, this variable switching price crosses over that blue hatched area there, that's where temporarily at least, you instead of going for coal power, you go for gas power. Now, that was around the end of 2015, start of 2016. It could easily have reversed soon afterwards, because you can see these are volatile. It's a sort of volatile marketplace where the switching price is wiggling around all the time. But what was really interesting is this first tipping point that looked reversible triggered other changes that became irreversible. So basically, the people who were invested in coal burning weren't making much money anyway in the UK. So here's one of the chief analysts talking about it. And this price change on carbon pollution basically switched the economics so that those who were invested in coal burning, probably including many British people's pension funds, were suddenly not making any money. And so the investors pulled out of coal. And then the utilities, the people who run the power stations, pulled out of coal. So this is a picture of a coal power plant. It's in Oxfordshire in the UK being destroyed. That's an irreversible change. And another one was destroyed just a couple of weeks ago in Scotland, actually. And they're all going. And the end result is shown in the black line here. In 2012, we still had 40% of power generation in the UK from coal, the black line. Now we're down at less than 2% over here somewhere. And most of the slack has been taken up by the renewables, the yellow, the blue and the green here. And it's meant that the UK has decarbonised the power sector faster than any other country in the world, including Denmark, which is famous for its wind power. So it's a sort of local or parochial success story, but the crucial thing is to think globally. And here the good news is there are these amazing economies of scale that are making renewable power cheaper and cheaper, and the more we deploy it, the cheaper it gets. So this is showing you how the price of solar panels, solar PV, declines on the y-axis as a function on the x-axis of the amount of solar panels you make. And it's just a spectacular decline in price by orders of magnitude. And it's projected that within a decade, we're going to have solar power so cheap in much of the world, it will generate electricity at like a fifth of the price of any fossil fuel. And that's the renewable energy revolution happening around us. It could be absolutely critical to the future well-being, for example, of a growing population in sub-Saharan Africa, the part of the world with the lowest access to electricity as it stands now. And if you're curious and you're looking at the triangles and the data and you're wondering, you know, what it wasn't going anywhere, and then suddenly after 2008, things really pick up. Why is that? Well, that was because 5 Chinese companies that made solar panels floated on the US stock exchange, and a massive investment of private capital was injected into that sector, and that kick-started this incredible resumption of progress in bringing down the price and deploying on large-scale solar power. So that now, if it weren't for the perverse subsidies and tax credits that still favour the fossil fuels, if you just look at what's the cheapest way of generating power country by country around the world, you get a map like this as of a year and a half ago. You know, you have large parts of the world where renewables are the cheapest power generating form already. Blue is wind power, gold or yellow is solar power. Okay, Russia, it's still gas in grey, and Japan, it's coal in black, and it's black coal in South Korea and a few other places. But the revolution is coming in terms of renewable power. The craziness of the situation there is that certain sovereign banks are still making it easier to raise capital for a given amount of power generation from a massive great coal power station than to do the same installation of, say, solar panels and wind turbines. And that has to stop, of course. Still, what I'm trying to emphasize is some positive tipping points are happening already, and they feed off each other. So I mentioned it already, but electrifying transport and meaning batteries get ever cheaper, that really enables the clean electricity revolution. But then if you were going to electrify transport, you want to do it with renewable power, with clean electricity. So they feed off each other. And then they start to open up other niches, like you'll have days in the case of the UK where the wind's blowing really hard, and you can dump electricity down into making green hydrogen, which you can then use to start to transform how we heat and cook in our homes, and so on and so forth. So the way we're thinking about it is there are these positive cascades of tipping points in society and the economy, which we're going to need to trigger so that we're going to avoid those bad cascades of climate tipping points in the climate I was talking about earlier. Just before I finish, I wanted to sort of get out of the highly technology economy driven stuff and talk a bit about how the same thinking would apply to our relationship with other living things and ecology, including our food systems, which obviously involve our relationship with other living things. So it's well known in ecology that there are tipping points and tipping cascades, and famous examples are like when wolves were taken out of Yellowstone National Park in the US, it totally transformed the whole ecosystem. And then later on, when they were brought back, it totally transformed the ecosystem, including the tree cover. And that's true for ecosystems across the world, across all geographies. And that's interesting and important, the fact that ecology is full of its own feedbacks and networks and interactions. This can be a bad thing when we are decimating the biosphere and we tip the degradation of ecosystems. But it also might really help us, because equally we could tip positive changes in ecological systems, including the ones that we derive, say, food from or other ecosystem services from. So to give an example, sort of fairly local scale, the picture here is of a blue mussel bed, so edible blue mussels, little bivalve shellfish. This is just a natural mussel bed. The mussels and the microbial mats around them, they stabilize the sediment underneath them to stop it all getting washed away by the tide. So they're sort of self-supporting in one stable state of flourishing mussel bed with its own amazing self-organized patterns at different scales that you can see. If you start to eliminate too much of the mussels, the whole thing collapses. But we can work with a system like that, and people are working with systems like that with very crude technology. If you just introduce some fencing, you can start to stabilize the sediments, let the mussels get a foot in the door, and allow them to regenerate a productive mussel bed, which we might then farm in a sustainable way. It's just an example of how, if we get engaged with and interacting with other living things in the right way, in the right kind of feedbacks, we can get ourselves towards hopefully tipping a transition to more sustainable food and land systems. And I admit that that is an area where we don't have the big scale of examples of doing it yet, but I've been working with the Food and Land Use Coalition. I've written a report with them where we show how this thinking could be applied to transforming food and land systems, and we give a few concrete worked case studies, one of which would be possible tipping point in changes in diet and also the penetration into the market of alternative proteins and plant-based meat substitutes, so that we basically get away from extremely ecological and climate damaging meat production, cattle and the like, especially red meat. So it's a rather prospective example, but we already see trends of sudden interest and uptake of diets. Veganism is on the rise again. We see new alternative protein sources and plant-based meat substitutes already beginning to penetrate the market, certainly where we are. I'm speaking from in the UK. And so we can certainly begin to map out what would it take to, what interventions could start to trigger a tipping point in that case for a key part of our food and diet systems. So that might begin to make this feel a bit more personal, because it's all very well me talking about what can the government do, but most of us are probably sort of scared by climate change and feeling a bit powerless. And I'm trying to show or explain that we all have some power or some agency to be part of the positive tipping points, and we don't have to be quite as courageous as my relative Lillian was. We don't have to put our life on the line or be in jail for something we believe in. Even just as consumers, we already have some power. Of course, as citizens, we can act politically, and we saw some examples of that. And that can also clearly be a key part of change. I've also tried to show how some of these examples hinge on moving capital around, finance, which shouldn't be a surprise to anybody. But if we can build the coalition, I think, of civil society, supportive policymakers, moving us some capital in the direction that propels the change we want, maybe working with the media and in education to tell a good story and a good narrative of the power we have to change things together, then I think a coalition like that of us agents of change is probably the best chance or the most effective vehicle we have to try and, first of all, kind of creating the enabling conditions for the positive tipping, and then actually doing the tipping. Yeah, well, I hope what I said is some kind of inspiration, and if it doesn't resonate for your culture or your geography, then let's have a discussion about how maybe some of this thinking can work in all kinds of cultures and geographies. I basically just tried to explain we're in a climate emergency. We're facing already damaging climate tipping points. We've got to try and avoid the ones we can still avoid. That demands that we do what it says in what's called the Paris Agreement. We limit global warming to well below 2 degrees C, but we've left it late. So now we've got to find some of these positive tipping points if we're going to do that. But I've tried to show you that there are real examples of that happening, where deliberate actions triggering these reinforcing feedbacks are already tipping some positive change. And I'm just hoping you take away from this that a little bit more of a sense of power and agency in the face of this daunting problem, because I honestly believe that we can all be part of triggering these positive tipping points. All right.